So here we go, 5, 3, 5, 4, 5, 6, and 5, 7. Good, just put them in a big old table. We good to there? Okay, now, first thing, what is the domain? They're asking us the domain. What's the domain? Well, domain is always the x values. So what's the domain? The x's? Well, just 5, huh? They're all 5. What's the range? Next question, what's the range? Range is the other side. The range is the y's. 3, 4, 6, 7. Final question, is that relationship a function kind of relationship? Is that relation a function? So what was the rule again? Let's go back here to number 1 again. So back here on number 1, the rule to be a function, every x must go with only one y. Every x, you can't have a single x going to 2 different y's, right? So let's go back. Do we have a single x going to 2 different y's? For sure. This one's not a function, huh? But this 5 is going to all kinds of different y's, isn't it? That's not a function. Good? Easy enough? Kind of a little weird, huh? Probably seems like, what? What a weird thing to do. But I don't think it's too hard once you've done a couple of them. Questions? 4 here. So number 4. So basically they're going to start off by saying, what's the domain? The domain's going to be the left side again. This is the domain. What's the range? This is the range. So that's their first 2 questions. Domain is left side, range is right side. Now, is that a function? These are the x's over here, right? These are the x's over here, and these are the y's. Remember the function rule. Every x, to be a function, every x must go to only one y. Every x must go to only one y. What do you think? Does every x go to only one y? No? Okay, so then tell me an x that doesn't go to only one y. What's that? Venus and Neptune, okay. So Venus, you're an x. Yes, I am. Do you go to only one y? Yeah, I only go to 18. Mars, you're an x. Yes, I am. Do you go to only one y? Yes, I go to 26. Only. I don't go anywhere else. Jupiter, are you an x? Yes, I am. Do you go to only one y? Yes, I go to 26. Only. This is good. Getting the hang of it? This is okay. The problem, I know you're probably looking right here going, what about this? This is no good. No. What would be no good? What would be no good is if Jupiter also went somewhere else, like there. Right? If Jupiter, a single x, went to 2 y's, that'd be the no-no. Getting the hang of that? So this one's okay. This one's okay. Right? So you could have them, you could have like all of them going to the same y. Notice you could have this. You could have like a bunch of dots like this, and they're all going to the same y. That's okay. That's okay. That would be a function. This is a function. Why? Because every x goes to only one y, doesn't it? And if you're not sure, just question them like I did. I wasn't trying to be goofy. I would just, if you're stuck on a test and you really want to get the points, just question them one at a time. Say, hey, how about this x? Does he go to only one y? Yes, he only goes to that guy. He doesn't go anywhere else. How about this x? Does he go to only one y? Yes, he does. How about this one? Get the idea? Even though they're all going to the same one, that's okay. They still each go to only one x. Well, the big no-no would be if this guy went to 2 x's. I'm sorry, to 2 y's. Right? Making sense? So this one is yes. Oops. Yes, it's a function. Good? On that. So what do you think? Is that a function? Yeah, that's like what we were just talking about. That one is a function. What's the domain? those things, right? So you just put them, they just want you to put commas between them. 2, any order, by the way, it doesn't matter. 2, -4, 6, 107. It's like that. What's the range? It just looks like 1, huh? That's it. And yes, it's a function. All those x's go to only one y. All the inputs go to only one output. Is that good? Is that making sense? So the vertical line test. If any vertical line hits 2 points on a graph, then it's not a function. Then it's not a function. So if any vertical line hits 2 points on a graph, then it's not a function. So what am I talking about? So what if you had, let me show you some examples here. So what if you had something like this? Here's a function, right? Or maybe it's a function, we'll see. So that one, vertical line hits 2 points, right? So that one's not a function. But how about one like this? How about like a U shape? Is that one a function? Yes, because every vertical line hits only 1 point, huh? Every perfectly vertical line hits only 1 point. So that one's a function. You tracking with me? So that's called the vertical line test. If you ever have you don't want vertical lines hitting 2 points. Why not? Because that's the same violation that we wrote out with words, just on a picture. What do I mean? Well, think about what this means if you have a vertical line hitting 2 points. That means that's the same x value with 2 different y values. Do you realize that? Well, let me just make up some numbers. Like maybe this is over, I don't know, 3, whatever. Over 3, up 4, maybe. I'm just guessing, you know. And over the same amount, though, whatever it is, it's over the same amount, say like down 4. See, that would be the same x, 3, going with 2 different y's, wouldn't it? Do you see that? See how a vertical line is the same thing as, you know, if a vertical line hits twice, that means there's one x amount, one over amount, right? The sideways axis is the x-axis. Do y'all remember that when I graphed? This is x, this is y, right? Sideways is x, up and down is y. Remember that kind of thing? So if you have a vertical line hitting 2 points, that means it's the same over amount, same x amount, hitting 2 different heights, 2 different y values. So that's just a pictorial way of saying what we said a minute ago. Every x must have only one y. You can't have a vertical line hitting 2 points. Same thing. So we have 2 ways to test for a function, with words and now with pictures. So let's go back to the problem then. So how about this graph? Is that one going to be a function? Yeah. Every vertical line will only hit one spot, right? I didn't do that so well. But yeah, every vertical line only hits 1 point. So yeah, I don't know why it has like all those words. The given graph is not, no, it's not okay. The first 2 are wrong, it says not. The given graph is a function because a vertical line can be drawn that will intersect more than once. Now, D. The given graph is a function because no vertical line hits more than once, right? Good on that? Number 7, is that a function? Should I make it bigger? Is that a function? Yeah, every vertical line hits only once, huh? So yes, it's a function. If every vertical line hits only once, that's good. Don't want to hit it twice. So there's number 8. Is that one a function? No way. Vertical line hitting a whole bunch of times. Not a function. Easy homework, right? Just whip over that. So here's their answers for number 8. The graph is a function. Okay, number 8 was not, right? Number 8, this is the one that was like this. So it's not a function. So is a function, no way. Is not a function because no vertical line, no. It's not a function because a vertical line hits more than once. D, right? We good on that? Everybody okay? So number 11 here, okay. So number is h of x equals 9x squared plus 1. And they're asking me for h of -1. Okay. So what do they want you to do when they put like the number in the parentheses like that? Do you know how, have you done functions before? Do you know how functions work? So we're basically plugging stuff in. So I want it to be real. A toaster is a function, for example. You have a toaster? A toaster is a function. What is that? What am I talking about? A function is something that you put stuff in, like you put bread in, push down the lever. A few minutes later, pops up toast, right? Put in frozen waffles, push the lever down, a few minutes later, toasted waffles. So a function is something that you put stuff in, it changes it and spits it out different. That's all a function is. So this is a function right here. And so we're going to plug stuff in and get stuff out. That's all functions do. So now, the x here, I really wish, if it was me, it wasn't up to me, but if it was up to me, I would have just put a blank there. That's what that x really means. When you see a function with those x's, you know, just think of a blank like the holes in a toaster, and whatever you put in here is just going to slide down right there. Does that make sense? The x in a function is just holding a spot. It's like a slot. It just says whatever you stick in the toaster is going to show up right there next to a 9 with a 2 on it, a 2 power on it. So therefore, what will become of it? It'll be -1 like that, squared plus 1, which will be what? 9 times 1, right? Because -1 squared is +1. We good with that? -1 times -1. So that's what? 9 plus 1, 10? So that means we put in -1, we got out 10. Like you put in bread, you get out toast. Put in frozen waffles, you get out toast waffles. You put in -1, got out 10. That's what just happened with that function. Does that make sense? Anything you plug into that function, it ends up being squared, 9 multiplied by it, and 1 added. So we could plug something else in, for example, to that same function. We could say, what's h of, I don't know, 2. Let's just do 2. Let's do h of 2. So what if you put 2 in that function? Well, it'll show up right there, won't it? So it'll be 9 times 2 squared plus 1. 37? I just worked it out. 2 squared is 4, 9 times 4 is 36, add 1, 37. Is that okay? Is it making sense how the function thing's working? So whatever you put in, it shows up right here, and then you just work it out, and that's what comes out. That's all a function is. Put stuff in, does something to it, spits out an answer. Makes sense? Whatever's in the parentheses is what you're plugging in. You put it in the parentheses in the formula, and then whatever comes out, comes out. Okay, so there's number 12. We're going to plug in 0. See what they're saying? Go ahead and try that one. See if it's making sense for you. They want to know g of 0. That's how you read that. By the way, it doesn't mean g times 0. This is g of 0. That's not multiplication. Those are the holes in the toaster. You're plugging 0 into the g function. So that means everywhere where you've got x, you're going to go 0, 0. Is that making sense? I could write that out a little bigger and with the slots there. So this is g of blank is 3 blank squared minus 2 blank plus 5. That's what that's saying right there. Right? Those x's are just blanks. So if you plug in 0, for example, and then you work that out, anything times 0 is just 0, huh? Those guys are just 0 plus 5. So it's just 5. Is that good? So you plug in 0 to the G toaster. How come 5? That's good. So whatever's plugged in, you just put it where the x's are. No questions. All right, 13's weird, so I'm going to move on if you're okay with that. F of x equals 1. Bless you. So what does that mean, f of x equals 1? So like, what if I put something like 6 in there? Right, because that's the first question, right? Plug in a 6. Notice there's no x on the other side. There's just a 1 over here, right? There's no x. That's weird. That's not normal. They're giving you a weird one on purpose. They're throwing a curveball at you. Normally, there's always a number, an x on the right side somewhere. So what does that mean then? Well, whatever you plug in, just might as well just throw it away, because there's nowhere it shows up on the right side. What's the answer on the right side? 1, 1, 1, always 1. That's all that comes out of that function. That's all that comes out. Does that make sense? It's like a trick question. It's because there's no x. If there was one x, if there was an x over there, then yeah, I would put a 6, you know, right? If there was an x, there'd be a place to plug in the number. But if there's no x, and then you just throw away the number. It's just 1. We good on that? So it's just 1. All right. Let's keep. So they're saying g of negative 1 is 5. Okay, so what does that mean? So when it comes to function notation on graphs, what it means is it means a dot on that graph. So whatever's in the parentheses is x. Whatever's over here is y. That's by common agreement. You know, same reason we drive on the right side of the road in North America. Why is it? There's not really a logical reason, right? We just agreed. They did it opposite in Europe, right? Just so we don't crash into each other. So that's all that's happening here. Why is it x here, y there? They just agreed. The math science world just said, hey, when we go functions, we put them on graphs, just make the thing in the parentheses x, and whatever answer comes out y. They just agreed. So that's the key. So just know that's what they agreed to do. So so this is x, this is y. So can you find that dot on the graph? You know how to read graphs okay? Remember, can you find the point negative 1, 5, x, y on a graph? Do you remember how that works? The first number is like the over, the sideways, and the second number is up or down. Remember that? So on the graph, starting at 0, 0 here, right here in the origin, you always start right there in the middle. Go back 1, that's the negative 1, up 5, 1, 2, 3, 4, 5. Right there, see how we're right on the graph there? That's the location. That's the dot, back 1, up 5. That dot right there. Is that too small? Can you see that a little bit? That's the dot, back 1, up 5. So that's what two numbers with the comma and the parentheses mean on a graph. The first number is sideways. The second number is up and down. So from the center, it's back 1, up 5. And that's that dot right there on the graph. It's in that dip of the graph. So that's what they're saying when they say that. Let's try the next one. Let's try 15. Number 15. And they're asking me, they're saying f of 0 equals what? That's their question. F of 0 equals what? So what is it I'm supposed to do? Well, remember, this is x by common agreement. Whatever's in the parentheses is x. Whatever comes out is y. So how in the world do I look at a graph and answer that function? So they're not even giving me anything to plug into. They just want me to read it off the graph. What am I supposed to do? What am I going to do? What I got to do is I got to find the point that has an x value of 0 and then find the y that goes with it on that graph. So can you tell me, where is the point? This graph is made up of millions of points, right? Millions of points. That's what a graph is. Graph's like a big light bright, right? Millions and millions of little dots all connected up. So millions of points. Can you find the one dot on that graph that has an x value of 0? Do you see that it's right here? How am I doing that? Well, because what are the coordinates of that point? That point is from the origin is over 0 down, looks like 6, huh? Over 0 does. Everybody see that? Like this point here this is over 1, looks like down 3. This point here, this is over 2, etc. Right? You see what I'm talking about? From the origin, if you go over 1, you got this dot. If you go over 2, you're at that dot, etc. So if you're over 0, you're at this dot, aren't you? That's the dot with an x value of 0. X, so it's always x first, then y. It goes alphabetical, right? This is the x-axis, the y-axis. Remember all that stuff from earlier classes? So basically they're saying, hey, find the point on the blue graph there that has an x value of 0. Find that dot. Okay, boom, I did. There it is. And give us the y value that goes with it. Okay, -6. Done. So there's nothing to compute as far as, add, subtract, multiply, or divide. It's just to read it off the graph. It's just all about, can you speak that language? Can you talk function graph? That's what they're wanting you to do. Is that good? Just find the dot that has an x value of 0 and give us the y that goes with it. Because whatever you put in the parentheses is x, whatever comes out is y, by common agreement. Questions I can answer? All right. So number 16, it says g of x equals 8, find x. Okay. Find x. So let me let you try that one real quick. G of x equals 8. Why g? Well, they're just calling this function g. They call the last one f. It's just a name, right? They could call it anything. So g of x equals 8. Find x. So look at that graph. Find a dot at 8. Now what do I mean at 8? What's 8 here? What is this 8? Is this x or y? Yeah, that's y, isn't it? Remember, x is in the parentheses, and y is what it equals. Remember when I gave it back here to you? I said it's always x in the parentheses and y on the outside. That's the key you want to remember. X in the parentheses, y on the outside. So this is x, which we don't know, and the y is 8. So what they're saying to us, is they're saying, hey, look at that graph. Find a dot with a y value, a height of 8. Tracking with me? Because this is the x-axis, and this is the y. So what is a dot with a y height of 8? See right there? Isn't that a dot on the graph with a y value of 8? That is the point. Well, what are the coordinates of that point? Looks like it's, starting from the origin. Starting from the origin is over 1, 2, 3, 4. Up 1, 2, 3, 4, 5, 6, 7, 8. So it's over 4, up 8. So it does indeed have a y coordinate of 8. Its x coordinate is 4. But is that all? You see the other one? Right there. That one is also at a height of 8. Oh, and this one too. All three of those are at a height of 8, aren't they? What's the coordinates of this one here? Back 1, 2, up 8. Back 2, up 8. That's the x, y. And this one is back, I don't know what it is. 2, 3, 4, 5, 6, 7. Yeah. Back 7 and then up 8. So back 7, up 8. All three of those have y values of 8, don't they? All three of those have y values of 8. What x's are they? -7. You can put them in any order. -2, 4. They want all three answers with commas. It doesn't matter what, you can switch them all around, it doesn't matter what order. But all three of those are x values, aren't they? That go with a y value of 8 on the graph. They're all three at a height of 8, at a y value of 8, aren't they? Is that making sense? Questions I can answer? Okay, so what, oh yeah, I should. So this is f of x equals 4x plus 5. They want me to graph it. F of x, function, it could be f or g or whatever. That's y, again, by common agreement. So f of x, let me write it up here for you. F of x or g of x or h of x is or are just y. That's by common agreement. So function letters, those are y. Again, that was Math Science World just said, all right, here's what we're going to do. Whenever we're doing functions on graphs, we'll just let the function thing be the y. That was by common agreement. So right away, I just change f of x to y. That's just what it is. Okay, so what then? So I'm supposed to graph this one. Now they assume you already know how to do that, but I'm not going to assume that. It is the previous class, graphing things like this, but I'm glad to help. Anybody remember some of it, like how you graph? You know, it's going to be a line for stuff. This is what we call a linear equation, meaning the graph will be a straight line. It won't have any curvature to it at all. It'll just be a straight line. How do you know? How do you know when you look at an equation if it's going to have bends in it, curvature, or just be straight? One at a time. I bet some of you know. It's about power. If they're both first power, just like, no, it's not x squared or not y squared or something, then it's just linear. It's going to be a straight line. Yeah, so it's just regular x, regular y, no powers, no x squared or y squared or, yeah, like absolute value or other weird stuff. Then it's just going to be linear. So this is just going to be a straight line because it's just regular x and regular y, not powers. It's like x squared and x cubed and stuff that brings the curves in. It's those powers. Okay, so it's just going to be a straight line, what we call a linear equation. So anyway, how do we graph it? How do we find the line? Anybody remember doing this? There's a couple ways. You can make a table, but there's an easier way. Have you done the slope thing before? Have you seen that before where you like march off the slope? Yeah. But you want to start with this number. Start with the number that's off to the right. Whatever number's off to the right, that's going to be up 5 in the middle. If that was minus 5, it'd be down 5 in the middle. So you start right there. So I'll go 1, 2, 3, 4, 5 right there. Well, I'm going to run out of room. Let me scoot it down a little bit. That's true, what I just did. I just need more room. So 1, 2, 3, 4, 5. Right there at up 5. So whatever number is off to the right, that's your first dot. I just need 2 dots, by the way, right? 2 dots, connect the dots, we have our line. So I'm halfway there already. I got 1 of my 2 dots. This number out here is called, do we know? The Y-intercept. You see that for you? Because it's going to be where our line hits the y-axis. It's called the Y-intercept. So whenever, have you seen mx plus b before? That's what we're basically doing. That's y equals mx plus b. This is y equals mx plus b. That number off to the right, that is where you start. It's the Y-intercept. So we got that. That's 5, up 5. That's your first dot. And now what's the 4? It's the slope. Yeah, it's the slope. And you got to make it look like a fraction. So how can I make 4 look like a fraction without changing its value? Put it over 1, right? If you put it over 2 or 3 or something, that would change its value. But 4 over 1, that's still just 4. And now I can do rise over run. Remember that from slope? Rise over run. So that means if you start at 5, see, I'm going to totally run out of room. I keep moving this thing down and I don't have room. It doesn't matter how many times I move it down. So I'm going to go 1, 2, 3, 4, 5 right there. So there's my first dot. And then from there, I'm going to rise 4. So I'm going from my first dot now, not from the origin anymore. But from my first dot, I'm going to rise 4. So I'm going to go up 1, 2, 3, 4, 1, 2, 3, 4, over 1. Connect the dots. There's the line. So I went up 4 and over 1. So that's how you graph lines. So whatever number is off to the right, that's your starting dot. And then from there, you go up 4 over 1, because that's rise over run, that's the slope. So the first dot comes from whatever number's off to the right, right in the middle. And then the second dot comes from rise over run from the first dot up 4 over 1. Let me show you how you do it on their little system. It's real easy, I mean. So let's try here. I'll just make one up for y'all. How about y equals 2x plus 1? Okay, so graph that one. So just make an axis system. You know, find your first dot, do the rise over run slope thing, find your second dot, connect the two dots with a straight line. Then we'll go to harder, weirder ones. Everybody get their exams? The old exams are up here. Feel free to come on up if you want to grab your exam from last time. Just grab an after. Wait. So where's our first dot? Up at 1, huh? That number off to the right? So we start up 1 in the middle. It's always on the y-axis, huh? So up 1 right there. There's our first dot. And then how do we go to get to our second dot? It's 2 over 1. It's up 2 over 1, right? Rise over run. So go from here, go up 2 over 1. There it is. Connect the dots. Straight line. Easy enough? Graphing lines? Questions on that? Now, so if you're okay, I'm going to move off that. They're going to start pulling negatives everywhere. So what do you think if they give me y equals negative 2x plus 3? Try that one. I bet you. So where's the first dot? We start up 3, right? And then where do we go from there? This is over 1 again. It's rise over run. Slope is always rise over run. So how do you rise negative 2? Down 2, huh? So from this dot, go down 2 over 1. Connect the dots. That line goes forever, but there it is. That making sense? So if it's negative, it goes down. Good on that. All right, let's. Okay, can you graph that one? F of x. Remember, that's just y. Y equals minus 9x. So try that one. Graph it. Where do we start? Where's the first dot? Yeah, because there's nothing out here. It's the same thing as plus 0, huh? So you start at 0, really. There's no number out there. So you start right in the middle, huh? 0 height. That makes sense? There's nothing out there. You just start at 0. All right, and then what do you do with the minus 9? You know, you put it over 1. That's your rise over your run. And so that means you go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go down 9 over 1, and then you connect the dots. It's going to be a very steep line going down. That makes sense? Down 9 over 1. Is that good? Questions? All is well? Okay, so try that one. See if you can graph that one. Minus x minus 1. So where do we start? I'll make it y equals minus x minus 1. We start at down 1, right? And then where do we go from there? Just straight down 1? Yeah, good. You got to make this 1 over 1, huh? There's nothing in front of that x, but that really means there's 1 over 1. Because that's 1. 1 divided by 1 is just 1, and 1 times x is just x. So I haven't changed any values, right? It's okay to do that. I haven't changed any values. And now we know what the rise and the run are, huh? Now we know the rise is negative 1. The run is positive. So it goes down 1, over 1. Like that. Connect the dots. There it is. Is that okay? So if there's nothing in front of the x, it really is 1 over 1, which is just 1. And 1 times x is just x. I haven't changed anything. Right? No values have changed. It's the same thing. Good? All right, I'll move on.